All right. Hello, folks watching this on the Zoom. So again, basic idea here, right? Want to make use of this lab time, and many of us are orienting towards trying to find jobs in technical fields, software engineering, data science. Long story short, technical interviews are a core critical component of that. And so a big process of kind of preparing for these is getting good at solving these kinds of coding challenges. Um, and so while not, again, strictly part of the curriculum, I feel like it'd be really, really useful for us to kind of work through, maybe do a problem a week type deal, type stuff. And so I'm going to sort of store these separately. Every week we'll do one of these together. I think it's good practice for Python in general, but moreover, it just kind of gives us a chance to work these out. So I sent out a link this afternoon. So if you don't have this already, LeetCode is probably the most famous tool for technical sort of challenges. It's sort of the best known one for these. There are others, HackerRank and whatnot, but this is probably sort of the most famous one for it. So you don't. Oh, are you able to do this without? Oh, you need to log in or okay, run to submit. So yeah, so you do need to create an account, but this basic thing is free. So let me log in. So this should be the problem here. Sorry, let me make the screen a little bigger. Those of you guys watching. So this is if you're following along. Try to make it super big. This is the two sum problem. All right, and I'm sorry, guys. I know the screen is terrible. I apologize. Okay, but again, this was what was sent out earlier. So, okay. Did any of you guys have a chance, either in the room or online, to look at this earlier? Not really. No? Okay.
Did not, no.
Did not. Okay, cool. All right, let me guys give you a moment. Pull up the code, pull up the website, sign in. You should see this, right? You should see the code prompt. You should see the space to do this, all that jazz. So you should sort of see all that. Oh, and by the way, change this right here, because you'll see there's a variety of different languages. We want Python 3. So it should look like this. So class solution gives you a def of two sum. It's a self because it's within class. And then it's going to take an input nums, which is a list of integers, target, which is an integer. And ultimately, we'll look to output a list. Okay. So you should see this. All right, I'm going to give you guys a moment. Anthony, when you got it up and running, let me know. And then Era, Raymond, let me just know if you guys are able to get this running. If you're doing it.
Yes, I have it up.
Okay. Oh, perfect. Okay. You have it up? Okay, cool. Actually, I'm wondering, I'm sorry, I'm wondering if I shouldn't share. I'm going to share a screen on this because I feel like the folks watching, this is going to be like,
That'd be great, thanks.
okay. Yeah, I feel like because we're getting in the weeds here. So let's just do this. Okay, I'm going to share screen. All right, then let me go. No, I want to go. Where am I going? Announcements. Slab. Okay. Two sum problem. Okay. So Anthony got pulled up? Yes. All right. So let's look at so okay, just sort of a little bit here. If you've never seen LeetCode before, if you've never sort of worked in an environment with this is a very sort of typical kind of thing here. So there's a problem prompt here. They'll usually give you sort of a problem description. Then they'll give you examples of inputs and outputs. and maybe even a description on that. If they're building in some constraints for it, they're going to sort of do that. And you may see here with LeetCode, there's a bunch of sort of things, topics, hints, discussions around it. I mean, there's a lot here. So, there's an editorial to sort of help you with it. Um, but the thing to note here is that like when you want to run your code, you can do this. When you want to submit it and test it against the test cases, you can sort of do that here. You would do that. And again, here is the actual code block where you would write your code. Okay, so let me sort of talk you through before we even get into the specifics of this problem, before we get into this. So this is very typical. Again, a lot of tech companies will ask you to solve something on LeetCode, on HackerRank, something like this will look a lot like this. Um, Oftentimes it's a timed challenge. So you might get like an hour to do this. So the first thing to note is how to take this test because you can obviously just copy this prompt copy this prompt and paste it into an LLM, ChatGPT. It'll get you code. It'll work and you'll solve it instantly, right? So the important thing to note when you're actually taking this test is that they do look at your final code, but they don't look at it in static. They look at the process by which you create this code. So they're going to be looking at essentially kind of how this is coming together. So if you just if you take the code and then 30 seconds later paste something and run it, don't you're not going to get a call back because they're going to say, okay, you plugged into LLM, congratulations, right? That's not what we're looking for. So they want to see you do the work, which means you're going to want to get into the habit of documenting your work as you're going along, thinking about your assumptions, experimenting, testing. Basically, they kind of want to see you messily put the code together. They want to see, they want to see how the proverbial sausage is made. That's what they're looking at when they're looking at with this. So part of this is you want to get the code, you want to get it right. But what I want to emphasize with you is that part of the skill of getting good at this is getting good at documenting as you go along. What are your assumptions? What is your approach? What are you trying to build out? Putting it all on the screen, commenting it, documenting it, testing it so that, because again, they're recording everything you're doing on the screen. They're seeing everything as it's coming together. They're seeing your thought process, they're seeing your logic, they're seeing you debug. That's what they're looking at. So when they give you that test. So this is not just a results oriented thing. It really is process focused. Okay. So I just want to kind of mention that up front when you were thinking about this code, how to sort of do it. All right. With that in mind, well, any questions on, I guess, kind of LeetCode in general or?
You said that when you apply to places, they'll have you do LeetCode stuff.
Yes, very typically, yes.
Um, how does that work? So this is a problem that you found on LeetCode.
This is a problem with LeetCode. And in fact, you may even see if you do LeetCode Premium, they even show you what companies have asked this problem and things like that. So they actually sort of store and catalog problems like this. There's different ways in that it will happen, but oftentimes what will happen is you'll get what's called a pre-screen. So, you apply to a job, you make it through whatever AI filter has, then they'll say, "Hey, congrats, Anthony, before going on to the next round, we want you to complete this pre-screen." And it'll typically be like one or two LeetCode problems. You'll be asked to do, you do that, and then depending on how you do, you get called into an interview. So this is sort of like a preliminary round type stuff.
Is this a sort of thing where let's say
Mhm.
you don't get the solution, you're not gonna make it through, or if you don't get a solution, but you're saying you show in your comments and stuff that you actually thought through the problem.
Yeah.
You just for whatever reason, maybe you ran out of time, or you just couldn't you got stuck somewhere in the code.
Yeah.
Does showing that process in your code help you make it through, even though you didn't finish the problem?
Yes. So it's going to depend on the company and it's going to depend on the level of difficulty of the problem. But generally speaking, it's not a binary, you either got the code or you didn't.
Yeah.
It Oftentimes, not always, again, it's going to depend on the company. Like you will read, for each company is a little bit different. Like for some companies, particularly the most competitive, they expect you to get it fully right, pass all your test cases. If you don't, like they're not even going to move beyond the test screen because, let's face it, they have so many applicants that they can afford to filter on that. But for a lot of tech companies, particularly the ones that will ask like very hard LeetCode prompts, they don't necessarily expect you to get it within the hour. But yeah, they want to see your process. They want to see you work through it. They want to see you experiment. They want to see you try to be creative. And that process will matter. And even if you don't quite get where you want to go in the end, if you get far enough along, they'll do it. Like heck, I applied to a place the other week. I haven't gotten a callback interview, so clearly I didn't do great. But like just as an example, like I got a version of my code working. It passed a few of my test cases, but it wasn't passing all of them. Something about my implementation wasn't working for a number of edge cases. I just didn't have time to work through and figure out what it was. So I kind of had to leave it there. And for some companies, it's good enough, right? There's like, okay, you got this far within an hour. It's good. Like we've seen progress, but other companies will say no. So, for that particular company, I don't know.
Another question.
Yeah, of course.
So, like I know for like, there's multiple ways to solve a problem in code.
Yeah.
Does that factor into like, I know there are some ways that are more optimal than others?
Yes. So that 100% is going to work in. So that's okay. So great question. So we will talk strategies for this, but yes, first pass, you want to get your code to work. Actually, actually a great. Let me talk about that. So, is there different ways about thinking about your code? Yes. So generally speaking, I don't know if any of you have taken like a computer algorithms course. So algorithms is a great course. I love teaching when I taught at UCLA. It's it's essentially a course most CS majors take at the tail end of their CS education. And the idea is like here, so you may remember sort of algorithm is basically sort of just a fancy way of basically saying a recipe, right? It's a systematic, uniform way of solving a problem. And the entire process of writing programming is essentially devising algorithms, coming up with this stepwise sequential approach for solving a problem. Now, there's one basic level, it's got to work, right? And beyond it's got to work for all the test cases. That's your sort of next level, right? It works for the usual cases, then it works for the outliers. So it works for all of your test cases. And that's already a win. Now, going beyond that, though, there's optimization. And you optimize around runtime efficiency. It basically says like how, because if you think about it, ultimately, computation costs money. Literally, right? Literally, particularly these days, like with everything's on cloud compute, the more time, the more compute resources it takes to arrive at a solution, the more expensive it is, less efficient it is. So what we really begin to care about in these extremes is runtime efficiency. So not just doing it, but doing it efficiently. So optimizing your algorithm for runtime. Now, again, that's sort of next level stuff. We'll talk a little bit about sort of potential approaches for that and how to think about notation, something like there's a whole, maybe I could even have a lecture about that, maybe. But that's generally that's what separates the good algorithms from the great ones is the runtime efficiency. Is can I get to a solution with the fewest number of compute steps, which ultimately sort of improves runtime and reduces compute resources needed to arrive at a solution.
How do you know if your approach is efficient?
Oh, that's a whole great question. So you basically it's a great question. So so when you take an algorithms course, so the first thing is you propose an algorithm, then you essentially argue you have to prove correctness of the algorithm. So that's there's a whole sort of logic. It's a fast. I love it because it's sort of a blend of computer science, but then also like logic. And so you basically have to prove the correctness of it. So how do you know this approach is going to work? How do you know it's going to, do that? How do you go about proving that? And then once you've done that, then you do a runtime efficiency. You calculate your runtime, and then you talk about why you think that is or is not efficient. What could you do to improve it? What could you do to expedite that efficiency? So, again, you may not have time to document all of that here. In fact, you probably won't. Um, but anything that you can document along those lines is going to be helpful for that. So, and again, this is, I think, week 3. So we're not, necessarily going to do that, but maybe towards the end, I may introduce some of those topics and maybe we can sort of talk about that. If this is something the class is really interested in, we can absolutely like sort of turn this into a little bit of a like technical interview prep, maybe.
Yeah, I think so.
Cool.
Like, I
Okay.
heard a lot of like, what is it like? Big O.
Big O. It's all about Big O. Yes.
I don't know what it is.
Okay. So Big O, so I will have an explicit conversation about Big O. It's actually great because I literally taught this at UCLA, so I can teach this. So I have the lecture material on this. So Big O is how we calculate runtime. It's basically Big O is like order of magnitude for how much it runs. And interestingly enough, generally, I mean, there's different ways of thinking about like Big O. We usually talk about worst case scenario. So, because oftentimes, like your algorithm, like if it's a search algorithm or something like that, it'll look for a solution. Sometimes it finds it really quickly. Sometimes, right? And then you can be like, oh, well, my runtime was 2 steps because the first place it looked, it found it, right? But you're like, that's not, that's not kosher. So you got to do more of like, so typically you could look at like average runtime, but oftentimes we think about like worst case runtime. So if everything goes wrong, and you have to run your algorithm to completion in order to get the solution, what does that look like? What's your runtime? And again, we talk in terms of sort of generalized order of magnitude abstractions. You don't need to give like a detailed accounting of every compute step. It's more order of magnitude how many it is. Because yeah, it's not, your algorithm, it doesn't matter if it's like 9 steps or 10 steps or 11 steps. It matters if it's, and you hear the N is the size of the data set, basically, the size of what you're doing it. It matters if it's N or N squared or N cubed or N to the N, right? I mean, you start getting into those things, you're like, oh my God, like this is unmanageable. But yeah. Okay. Should we do this problem?
Good.
All right. Okay, so again, first thing we're gonna do is we're gonna sort of read through it. To sum. Given an array of integers, so num. So we have array of integers, nums. Integer target. Return indexes of the 2 numbers such that they add up to the target. You may assume that each input would have exactly 1 solution, and you may not use the same element twice. You can return the answer in any order. Okay. Now, one bit of advice I'm going to give for this. Write it down. Like, again, everybody's a little different. One thing that helps for me is literally to write down what you have and just to try, because there's something about, I don't know, maybe it's just like my age, but like something tactile about just having a pencil and paper and being like, okay, I have list of integers called nums. I have this target. And then my return is the indexes, because that's a big thing. The index of the 2 numbers that add up to target, right? So basically, I'm given a list, has a bunch of numbers. I'm given a single target number. 2 of those numbers in that list are going to add up to that target. This program is asking me to return those 2 indexes. All right, so looking at examples is really helpful. So, okay, so let's look at example 1. So your input, numbers equals. So here we have 4 numbers here, 2, 7, 11, and 15. Target is 9. What is the output here? Output is 0 and 1. What does output 0 and 1 mean? Why? Because num's index position 0 is 2. Num's index position 1 is 7. That equals 9. So the algorithm, our program here, is going to return 0 and 1. Okay, so again, it's not returning the values. It's not returning 2 and 7. It's returning 0 and 1 for the index positions. And oftentimes, by the way, LeetCode kind of does this. There are these little sort of wrenches in for these things. Okay, let's look at example number 2. Nums 2, 3, 4, target is 6. So in this case, it's going to return output 1 and 2. Why? Because index position 1 is 2, index position 2 is 4. Add those together, it is 6, right? Okay. So, and then sometimes it puts these constraints, and these may not be relevant to us. We may or may not do something like this, but it tells us that the length of our numbers, so the list is going to be between, so there's at least a minimum of 2 numbers. So that actually is potentially useful. So we have to deal with an edge case where there's only 1 number. That's useful. If up to the 10 to the 4th, that may or may not be relevant. The value is between 10 to the 9th and negative 10 to the 9th, and the target, same thing there. Also, there is only one valid answer exists. So that's also very useful because we know there's only one unique solution. That's another big thing to look at with this. Oftentimes when you're thinking about scoping a problem, is there only one solution? Could there be multiple? Do you have to only return one solution, right? Because sometimes you have to sort of think about that. Are you returning the first solution? Are you returning the only solution? Things like that. Okay. So, and then you'll see sort of a big O notation here. We're not going to worry about that for now. This is already a lot for first night stuff. Okay. So, and then you're going to see here, so they wrap it up, typical sort of LeetCode will oftentimes wrap this up in a class, but you don't need to worry about the class. You're just returning here. You're returning a class method, basically. You're just returning this function here. You just need to worry about this function here. And again, it takes in those 2 inputs. It takes in nums, which is a list. It takes in target, which is an integer. And it's going to output a list of integers, which specifically is going to be a list with 2 values. Okay. So, I'm going to pause the recording here. I want to give you guys a few minutes to think about this. And then let's, as a group, sort of talk about how we want to approach this, okay? All right, so I'm going to pause. All right, guys, let me hear some thoughts. What are we thinking?
I was thinking, I'm gonna go through the list. And then, so if I'm at the first index, I'm gonna loop through the list, all the indexes.
Mm-hmm.
And then as long as there's an index after the index I'm at,
Mm-hmm.
I'm gonna go there,
Mm-hmm.
add it to this one, check if it equals my target. If it does, then I found my 2.
Mm-hmm.
And then my answer is this index, and then whatever, however many away from this index
Mhm.
I had to loop through. If not, I move to the next one, and
Mhm.
just keep doing that.
Okay. Yeah. So I think there's sort of a basic idea there. Folks on the Zoom, anybody got some thinking along those lines?
I was thinking of setting up a for loop to iterate,
Mhm.
and if I noticed that one of the entries, so I set up a boolean where I compare the current value versus the goal,
Mhm.
and if the number minus the goal is greater than 0, or if the goal, sorry, if the number versus minus the goal is 0 itself, then
Mhm.
I'll append it to a new list and return that new list.
Mhm. Okay, I think good. So Anthony, Raymond, I think you guys are all perfect. I think you guys are all thinking along the right lines. And here's what I would say about this. It's a good place to start, is always to think through a brute force approach. And that, it's not a bad thing because remember, with this, time is money, right? And oftentimes we want to say, okay, let's get something working. So your basic instinct is, I have a list of numbers. Let me just go through the list, and for each number, see if there's another number that, that added together are going to equal that number, right? So, loop this number and then loop every subsequent number in it, and then see if any of those numbers sum up to that target number. If they do, try to figure out what the index position is for them, right? That's generally the approach. And that's good because here's, and by the way, write this down, right? Talk about your logic, write it down. Again, get in the habit of documenting this. And then when it comes to sort of devising an algorithm, this is always a good way to start because, and you always want to sort of think through, okay, is there sort of what is the most brutal way to do it? The most blunt, inefficient, elegant way to do this? I just need to get a solution. And you want to try to get it working. Once you get that done, then you can sort of play around with it and say, okay, well, is there a way for me to sort of play around with this and optimize it? And there's some specific strategies that you can sort of play around with to try and optimize. So like I have a solution that I came up with. This may or may not be the best solution, but I think it optimizes along. So it takes your basic idea, but we optimize it in a few interesting ways because there's a few sort of complications with this. The first is, as you may recall, we need to not return, don't return number, return index. That's a big one because we can't just return the two numbers. We need to figure out where they are in the list. And so you can sort of think about ways to do that. You can sort of do, counters or things like that, or we could just try to sort of potentially store it. The other thing is, oftentimes we sort of, in this case, have to keep track of a, how do I state this? We have to sort of potentially, depending on how we're doing this, we may or may not have to sort of build a parallel data structure to track what values are at what index positions, basically. And so, right, we may need to sort of notate what values are at what indices. Maybe, depending on how we do it. I'm sort of doing that. I'm not convincing you necessarily need to, but that's sort of what I do with this. Simultaneously, and this is sort of an interesting optimization thing. Sometimes the create and check are 2 steps. Sometimes they can be consolidated to 1 step. Okay, and this is sort of another thing. So traditionally, when we've been algorithms, our approach has been, if I need to create a custom data structure, right, create that first and then check it. But sometimes you can sort of consolidate that into a 1-step process. And why do you want to do that from an algorithmic perspective? Well, it's the difference between, so remember we talk in terms of n being the size of your data frame. Like in this case, n is going to be the size of our list. So if I'm creating, if I'm creating a data structure, that's going to be some magnitude of n steps, right? And then if I'm adding a whole, and I'm then reviewing the thing, that's going to be a whole nother loop through n. So that's going to roughly be order of magnitude of 2n. 2n order of magnitude. Whereas if I go through and at the same looping through n, I potentially create and check, that essentially is order of magnitude of n. Because instead of having to loop it twice, I'm doing 1 loop. I'm just maybe doing, a series of steps for that. So either way, actually, both of those are technically order of n, but, we still sort of consider that sort of a slightly more optimal thing. Okay, so what's this going to look like? Again, we don't necessarily have to do this, but the first thing, are you guys familiar with the enumerate function? All right, you're familiar with it? Awesome. Okay. So if you're not
Yes.
familiar with it, so enumerate is kind of an interesting way, and maybe that popped in your head when you were thinking about this, of getting both indexes and values, right? Because it's just like with dictionaries, we have the items function, so we can sort of do that. So you had the idea of looping, right? Looping the list, but here's what I'm going to say. Instead of just looping the list normally, instead of saying, for, num in nums, right? Rather than doing that, we're going to say instead for I and num in enumerate nums. And by the way, here, I'm just going to print index. I'll do this as an F string. So that. So first thing I'm going to do is I'm just going to run this. I'm going to test this. It's going to yell at me, but that's fine. I'll put, my thing is null. I don't want it to be null. I want to print it. Oh, that's annoying. Why am I not? Let me see. Okay, yeah, test result. Okay, wrong answer. Yeah, that's fine. Okay, good. Yep. Okay, so by the way, I'm running here. So index position 0 is 2, 1, 7, 2, 11, 3, 15. Perfect. Okay. So you can sort of see here how just by, so changing my loop here, right? So again, this is an example. Rather than just looping the number, by looping the enumerated, I get index and number. So already I got something to work with there, right? Okay, so now the first thing I'm going to say is, okay, for each number, what is the target that I'm going to need? So in this case, I'm going to say, I'm going to call it like residual. Residual equals target minus number, right? So that's the first sort of bit of information I'm going to collect here. So if so like in our test instance here, 2, 7, 11, 15, target is 9. So if it's 2, my residual needs to be 7. If it's 7, residual needs to be 2, right? So that's going to be the first thing I'm going to calculate. So my current number is this. What is my residual going to be? So now, here's what I'm going to do. Here's what I'm ultimately going to do. And this is kind of what I played around with here. So when I was playing around with this, I was like, okay, well, this is a little bit kind of annoying. But now what I'm going to say is, what if I create if I use the dictionary, because remember, I need to store, so what got me down this line when I was thinking is I need to store number and I need to store index. So what if I created a dictionary? And this is actually what I did the first time. So when my first sort of blank thing was I created a dictionary where each key was a number and each value was I. So okay, and actually, so let me write this out in sort of a blank thing here. So I would say here, so first I would do this and then I would say, okay, so for I, num, and enumerate nums, I would say, okay, so I create a blank dictionary here. I would call this, I don't know, numbers equals, here'd be my little blank dictionary. And then I would say here, I would say, okay, numbers, oh, sorry, numbers num equals I. So I would go through, so I'm going through here and I'm creating this dictionary. And with each one's here. And then when I have that, so once I did that, so I looped through and I created this dictionary. When I had that, then I then said, okay, for num in numbers, then I calculated this. residual is this. And then I said, if residual in numbers. Because remember, there's a logic check that you can do to see whether or not a key exists in a dictionary. And that's just to see that there. So remember, I'm looking here. So I've created this dictionary of numbers where the key is the number and the value is the index. So then I ran through this and I said, okay, I calculated the residual. And I said, if that residual for each number, if the residual is in there, so if that exists, then return numbers num, comma, numbers residual. Okay, do you guys see what I'm doing? Does that make sense so far? Okay, and if I'm running this, it's possible this will work. Let me see. I optimized a little bit, but ooh, 49 out of 63 cases passed. So you see here. So I am getting, so something about this is not working. Okay, so what am I getting wrong? Okay, so target is 6. Okay. Why is mine? Oh, okay. So interesting thing here. So I'm looking at this. So this fails. And the reason this fails is because uniqueness. So you can't reuse this. So theoretically, I could actually try to fix this. But so you see, most of my test cases, so this is an interesting example, right? Where a lot of these passed, but I'm failing some of them. I'm failing particularly here because 3 and 3 will work. So unfortunately, it looped 3 and then it looped it again and immediately stopped there. So I could probably fix this by adding a check to make sure residual does not equal num. Right? So that's probably how I could fix that. But I want to show you a little bit more of an optimized way that I did this, that actually sort of took care of this in the process. Which is, I can take this and turn this into sort of a single loop. So rather than looping and creating it first, I'm going to instead loop and create and check at the same time. So that idea of sort of consolidating those steps. So let's see here. So I'm going to grab this. So numbers. Okay. Okay. So let me comment this out for the moment. Let me go back to here. So rather than just creating this, I'm going to again calculate residual here. All right. So now I'm going to do this logic check here. If residual in numbers. And you're going to say to me, well, Lionel, hang on a second. If this is a blank list and you're doing this right now, how is this going to work? Well, the interesting thing is the way this is going to work is if this is already there, then that means, because remember, you're going to loop through this once. And so we know, so you're going to hit a pair. When you hit the first part of the pair, the opposite pair isn't going to be in here yet, right? Because you haven't created the dictionary entry. So it's not going to be there. So you're going to create that dictionary entry. Then you're going to continue going on and on and on. And then when you hit the second one is going to be there because the first one was already there. So it's going to pair up there. So if the residual was already in there, then it's going to work. Then you just return. Where's my little return statement? Now I can just return this. Return, right? Numbers original number there. If it doesn't, because it's the first time through, then I create this. Then I say numbers residual equals I. So you notice how I'm doing two things here. So I'm consolidating this down to basically my program now is going to be a simple loop through. I'm going to loop through it, and for each number, right? So I'm going to loop through, so here using this test case here, I'm going to loop through it 2. I'm going to say, okay, the complement of 2 is going to be 7. Well, that doesn't, so that hasn't been created. Let me think here. Wait a second. Actually, is this going to work for me? Wait, let me run this and make sure it works. It worked earlier, but let me just check. Yeah, no, okay, now I'm getting to none. Okay, well, that's great. What was my logic here? I think. Right, comma user, where's num? Chart. Oh, I know what my issue is. I'm just okay. The reason this failed is I actually can just return I here. So that's why. So don't do the original number because in this case, I haven't. So the reason this failed was because my first loop number 2, I haven't created the index for that, but I can still return that index directly just as I. So let me see if this will work. Oh, well, somehow I've gone down. I'm doing worse than before. All right, let me run these. Man, I had this beautiful logic. Maybe I should have done the brute force. Maybe I should have gotten the brute force working. Let's see. Num any numerator limit nums, right. In numbers. Turn. Oh, that should be num. I have to create the index. That's the problem. Okay. I think that's where my logic went wrong. Check this. Woo! Okay. All right. So this is a good example of get your code working first and then try to optimize. So, okay, so here's where my here's where my ultimate logic kind of went with this. Okay. I'm creating a blank dictionary here. And then I'm going to say, okay, I'm enumerating. So I'm going to grab index and number for each entry in my numbers index. I'm going to calculate the residual, right? So whatever my target is minus that current number. So the first thing I check is I say, okay, if the residual is in numbers, so if that residual already exists, right? If I've created an index position for it, then return the current index, right? Because I'm looping through, so I'm grabbing the current index and the index of that residual, right? So that's what I'm returning. If it doesn't, then create an entry for this index position. So whatever this index, right, create wherever this number is, add an index for it. So the idea is just, so, when I'm looking here, so if I'm looping through my algorithm here, my algorithm starts with 2. It's going to say, okay, residual is 7. Does that exist? No, it doesn't exist. Okay. So now I'm going to create an index position for this. I'm going to say index position numbers 2 is going to be index position 0. Then I go to 7. 7, okay, now I'm going to say the residual is 2. And I'm going to say, okay, well, is 2 in numbers? Oh, yes, right? I just created that entry. Cool. So now return that index, which is 0, and the new index, which is 1. So that's why this passes now when it didn't before. And by the way, it also takes care of the issue I had previously. Because remember, previously, the problem was the way I'd set it up previously, when I had identical numbers, like the 3 and 3 to give me 6, the problem was it was looping over the same thing twice. So the cool thing about this is it will touch on every number only once. It'll say either it was, right, either you've, either, and when you hit the first number in the pattern, since the other number isn't there, it'll create the entry for it. And then when you hit the second number of the pattern, it'll go back and say, oh yeah, the first number, I already encountered that. It's basically how you're looking backwards. So rather than like a forward-looking thing where you're saying, hey, this number, is this looking here? I'm instead kind of looking backwards and saying, hey, did I already encounter the partner of it? If not, I create it and go for it. Now, is this good? You know, I don't know. You can sort it's interesting here because you can sort of see here. Ooh, okay, it's a pretty good runtime complexity. Cool. So I got a good runtime complexity. Cool. So you can actually see sort of optimized things. So my memory optimization isn't great for this because I'm creating a brand new storage thing, but my runtime, ooh, look at that, optimized things. All right, any questions on this approach?
Um, I don't know if it's more of a question for the LeetCode platform, but how does it like compare your solution to previous solution to see like how optimized or how efficient yours compared to others, or
Yes,
is it
that's
just
exactly what it does.
oh okay.
Yeah, so you can see here runtime. So it's comparing me against, so it's checking all my use cases,
Uh-huh.
test cases, so 62 test cases, and checking my runtime. So my memory utilization, my processing runtime utilization, so things like that.
Okay.
So yeah, so it does compare it the rest of the thing. Now, final thing I'm going to tell you guys to do. Do this yourselves. Okay? Go through the process. If you guys, when you are serious about this, get a LeetCode subscription. Start practicing. Do a few of these problems every day. Easies, mediums, build up to hards. Sort of get in the practice of doing these. When you've solved this, when you've done this, go and plug this into like a chat GPT thing. Okay. After you've gone through, go through, and if you get stuck, you get stuck. Like go through the process, basically. You know, give yourself time. Like say, okay, I'm going to spend 30 minutes on this. Okay. You know, get as far along as you can, try to get it working. And then when you're done, plug it into like Gemini or Claude or something like that. And see the solution that they get. Because inevitably the LLM is going to do a better job. Inevitably. But the point is you'll learn from that then. Because one, you'll be intimately familiar with the problem because you'll have wrestled with these edge cases, you'll have wrestled with these issues. And then you'll sort of see how, oh, you know, okay, what's a more optimal approach to this? And then you'll sort of learn from that and you'll be able to apply that to your own thing. So, and again, another thing I want to emphasize is, you know, don't stress if you found this challenging or, you know, things. There's a very particular way of thinking about LeetCode. It's just like, to be blunt, it's just like standardized testing in a way, like the SAT or the GRE or any of those things. This isn't necessarily reflective of the kind of work you'll do as software engineers. These are particular types of problem-solving challenges. They ask questions a certain way, they structure things a certain way. There's a way of thinking about this that you will train yourself in. Again, much like the way you trained yourself with the SAT, you know, way back when, right? You sort of you study for the test. It's the same thing with LeetCode. You're studying for the test. And this isn't, again, reflective of the kind of work you'll actually do as a software engineer. This is more just getting you good at solving the kind of problems LeetCode asks. So,
Sounds good.
all right, excellent. All right, any other questions on this particular challenge? All right, cool. I'm going to end the recording there. And again, I'll be posting this one. Maybe I'll just do it as a separate section. I'll do it as a separate section. But yeah. All right. Well, hey, have a great evening.